This was a unit 1 from January 2024. That was also a mock paper, the mock 1. The first ionization energies of the four successive elements in the periodic table are shown. Which element has a 4 electron in the outer shell? So how we can, like these are the successive elements in the periodic table. So when we move across the period, what happened to the ionization energy? Ionization energy means the minimum possible energy which we need to remove the electron. So what we have, like the elements have the atoms with the full outer shell. So which element has a full outer shell? So the one which is required the most energy, so that is Q. So B will be the right answer, because if it has a full outer shell, it means it needs a maximum amount of energy to remove the electron out from it. Then which element could be in a gaseous covalent compound with the formula X? So means which one is a group 1 element? Sorry, group 7 element. So how we identify the group 7 element? So if this is group 8, and these are the successive elements. So first from the information we identify, this is group 8. So before group 8, which element will be there? Group 7 will be there. And then after group 8, the shell will change, and then we'll come back to, because like when we move across, this is position of the Q, so this will be P. Q is group 8, so P will be group 7. And then the next element, because these are the successive elements, so next element will be group 1, and then next element will be group 2. So which will form a covalent bond? So it should be a group 7 element. So which one is a group 7 element? So it shows P is a group 7 element, because Q is a group 8 and these are the successive elements. So P should be group 7. Then which element could be Y in ionic compound with a formula YF2? So means a group 2 element. So which one is a group 2 element? So we already identified that S should be a group 2 element. So the answer will be S here. Then which element has the atom with a larger atomic radii? So the period change, as the period changes, the size will also change. For example, they will have different number of the shells, but R and S will have different number of the shells. Then as a result, what will happen as we move across the group, the size decreases. As we move across the period, the size decreases. So R and S will have more electron shells than P and Q. So definitely they will have a larger atomic radii. But when we move across, the size will decrease. So the size of the R will be greater than S. So from the first only we identified, because we mentioned that these are the four successive elements. So this is group 8. So before group 8, we'll have group 7. And after group 8, because the shell will change, so we'll have group 1 and then we'll have group 2. Is it clear? Part B. Okay, look. So actually, yeah, okay. The whole question is actually from the first line you can solve. The first ionization energy of the four successive element means these are elements. Successive element means like if one is having a proton number, say 10, other will have 11, then 12, then 13. So which element has atom with a full outer shell? So full outer shell, which will have the highest first ionization energy. So means this is group 8. So if Q belongs to group 8, element before Q will be group 7 element. an element after, because group 7 is here. So it means P is group 7, Q is group 8, Q is group 8, then R is there, group 1, and S is there, group 2. Because they are successive element. Like if this has example of proton number 9, this will have proton number 10, this will have proton number 11, and this will have proton number 12. So they are the successive elements. So this will be group 1 and this is group 2. Now they're saying which element that could be X in a gaseous covalent compound with a formula of HX. Means a covalent compound is there, so it cannot be group 1 or 2 because group 1 and 2 will form an ionic. So it cannot be R, it cannot be S. Q is a group 8 element. Group 8 elements are inert or unreactive, does not react. So what we are left with, P only, the group 7 element, because like group 7 element, when it combined, like hydrogen combined with chlorine or hydrogen combined with fluorine, it will form a covalent bond. Is it clear? The next is, which diagram represent the electronic structure of a nitrogen atom? Nitrogen atom, it is 7 and 14. So it will be 1s2, 2s2, 2p3. And when p3 is there, because px, py, and pz, so first it will be occupied singly. So then C will be the right answer. Which species does not contain a total 16 neutrons? So a molecule of ethene. Ethene is C2 and H4. So when you count the number of the carbon, like neutrons of the carbon, because we need the neutrons of each. So carbon is having like 6, because this is a nucleon number is given in carbon 12. So 6 minus 6, it will be 6 neutron. So 6 neutron multiplied by 2 for carbon. Plus hydrogen is having, hydrogen 1 is there. So hydrogen does not have any neutron because 1 proton number, 1 nucleon number. There's no neutron in hydrogen 1. Hydrogen 2 has 1 neutron, but hydrogen 1 does not have any neutron. So 1 neutron multiplied by 4. So it will be like here, it will be 6 multiplied by 2, 12. And there is no neutron here, sorry. So it will be 0. So 0 multiplied by 4, it will be 0. So it will have 12 neutron. That's why A does not contain 12 neutron. A contain only 12 neutrons. A does not contain 16 neutron. A only contain 12 neutron. What about oxygen? O2 is there. Oxygen molecule. Each oxygen is having 8 neutron. And there are 2. So it will be multiplied by 2. So make 16. Silicon, it's 14. So 16 minus 30 minus 14. So that will be 16 neutron. And multiplied by 1. Because there is only 1. Sulfur, 16 and 32. So 32 minus 16, it will be 16 neutron and multiplied by 1. So that will also have 16. Only in this case, because it will be 6 multiplied, 6 neutron multiplied by 2 plus 0. Why 0? Because hydrogen does not have any neutron. So that's why A is the right answer for this. Each response gives the atomic number of the two elements. Which pair of atomic number are those that are different blocks of the periodic table? So this is giving atomic number. So when you write the configuration for 5, like 5 electrons are, 5 protons are there. So it will be 1s2, 2s2, 2p1. And for 9, 1s2, 1s2, 2s2, 2p, 2p5. So means they are both p, because they are both p block element. The last electron is in p shell. What about 10 and 16? Even you can do this question from the last periodic table is given. like 10 and 16. So just check 10 and 16 belongs to which reagent. Proton number 10 and proton number 16. Like here, if you see proton number 10, proton number 10 is neon and proton number 16 is sulfur. So means they are S block element. So they are the same. 13 and 18, you can write the configuration or you can check from here. 13 is 13 is aluminium S block and 18 is argon S block. So it means D should be the right answer. Because that is the only thing, only one we are left, 16 and 20. So 16 is sulfur, which is a P block element, and 20 is calcium, which is S block element. So means they don't belongs to the same blocks. That's why. The correct answer for this one will be D. Because this is S block, this is P block element, and this is S block element. Which molecule is a polar? So carbon dioxide, both oxygen linear structure, so they cancel out each other. Carbon tetrachloride, identical atoms are attached, cancel out. Beryllium chloride, linear structure, cancel out. But in ammonia, even though identical hydrogens are there, but it is a bent structure like a trigonal planar or pyramidal. That's why ammonia will be the polar molecule. The polarity of a molecule depends on the geometry of the molecule. Which oxide of a nitrogen contains 30% nitrogen by mass? So if we check, this will be 14 divided by 16 plus 13 to 100. This will be 14 divided by 14 plus 16 into 2 multiplied by 100. Because like if we need the percentage, so mass of nitrogen in a compound divided by total mass of the compound into 100. This will be mass of nitrogen in a compound divided by total mass of a compound multiplied by 100. This will be the mass of nitrogen in compound 14 multiplied by 2 divided by 14 multiplied by 2 plus 16 into 100. And this will be mass of nitrogen in a compound 14 multiplied by 2 divided by 14 multiplied by 2 plus oxygen is 16 into 3 into 100. So you have to check which one give a 30% nitrogen by mass. So it will match with option B, nitrogen dioxide. Calculate the mass of sodium carbonate that is required to make 250 cm cube solution of concentration 0.1. So first we'll find we have the volume. It will be 0.25 decimeter cube, and we have the concentration. So first we find the moles. Moles is concentration into volume. Concentration 0.1 and the volume is 0.25. So it will be 0.025. This will give us the moles of sodium carbonate. Then we need the mass in gram. So mass in gram is molar mass multiplied by moles. Molar mass of sodium carbonate. Sodium is 23 multiplied by 2 plus carbon is 12 plus oxygen is 16 times 3. So this will be the molar mass of sodium carbonate multiplied by the moles of sodium carbonate, which is 0.025. That will give us the mass in gram of this sodium carbonate. So 2.65. So B will be the right answer. A block of a lead measuring 10 cm, like dimensions are there and contain atoms. Calculate the density in gram. So first we have this many atoms. From atoms we will convert into moles. How to convert atom into moles? Moles equal number of atoms divided by the Avogadro's constant, 6.02 exponent 23, this value. So number of atoms are 3.295 exponent 25 divided by 6.02 into 10 to the power 23. This will give us a number of the moles. After getting the number of the moles, you need the mass in gram. So the mass in gram we just did now. Mass in gram is moles multiplied by molar mass. In this case, because it is an atom, so atomic mass. So mass in gram will be moles, which is this value, this whole value, and multiply by the molar mass. The molar mass of or relative atomic mass of lead is 207.2, and the moles from here. When we multiply, we get mass in gram. And to get the density is mass over volume. So mass in gram is there, this answer. And what about the volume? The volume is the dimension of a block 10, so it will be 10 cube. So this answer divided by 10 cube, that will give us the density of a lead block in grams per centimeter cube, which will match with option C, 11.34 grams per centimeter cube. For any question, if you want me to repeat or you're not able to understand, you can just let me know in a chat, or you can also use your mic. I will repeat that. Which are the correct bonding and structure of substance listed? Substance copper sulfate. The type of the bonding in the copper sulfate covalent. No, copper to sulfate, actually it will have covalent and ionic, both bonds are there. Why? Because copper ion is there. In a sulfate ion, sulfur and oxygen will have a covalent bond with each other. And the attraction between the copper ion and the sulfate ion, it will be ionic. So what kind of bonds exist in a copper sulfate? Both ionic and covalent. It has a giant structure, but it does not have a right bonding. Graphene is having a covalent structure, that's fine, but it does not have a simple molecular structure. It has a giant structure. Iodine is a non-metal, so bond it will have a covalent bond. So bonding is structure is correct, but the bonding is incorrect. For sodium, it will have a metallic. Look, remember, metallic, ionic, and giant covalent, like they are all like giant molecular or macromolecular covalent structure. They are all giant. The three types of structures. So D will be the right answer. In question 10, an excess of a sodium sulfate solution is added to 50 cm cube of 0.1 mole per dm cube solution of a barium chloride. What is the mass of a barium sulfate form? So first, using the volume and the concentration, we'll work out the moles. Moles is concentration into volume. So 0.1 multiplied by 50 divided by 1000. So 0.1 multiplied by 0.05. So this will be 0.005. These are the moles of sodium sulfate. Then we need the moles of barium sulfate, like we need the mass of barium sulfate. The ratio is 1:1. Like 1 mole of sodium sulfate give 1 mole of barium sulfate. So if we have 0.0005 moles are there, this will be X. So we get the same moles. And then to get the mass in gram, just multiply by the molar mass. So it will be multiplied by 233.4. So multiply by the molar mass, that will give us the mass in gram. So 1.167A will be the right answer. Which compound shows the greatest degree of polarization? If the polarization depends on the charge of the positive ion, it should be large. The size of the positive ion should be small. The size should be small and the charge should be large. And the size of the negative ion, should be large, and the charge on the negative ion, like if it is having a greater charge is there, so it will be attracted more. So the size and the charge for the negative ion should be greater for distortion, but size for a positive ion should be small and charge should be large for a greater polarization. So sodium chloride, sodium iodide, magnesium chloride, and magnesium iodide. First thing, when we compare the size because sodium and both magnesium, these are isoelectronic, they have the same electronic configuration 2,8 and 2,8. But because magnesium is having more protons, so magnesium will be small. So magnesium will be small, so and it will have a large charge. So any option with magnesium is correct. Then what about the negative ion? As we go down the group, the size of the negative ion increases, more electron shell. So as a result, this iodine will have greater distortion as compared to that of chlorine. So magnesium iodide will show a greater polarization as compared to magnesium chloride. Lattice energy is different thing. Lattice energy, the size should be small for both of the ions and the charge should be large for both ions to have a very high lattice energy. But this is about the polarization or distortion. A sample of a seaweed contains 30 milligram of iodine per kg. What is the number of iodine atoms in 10 kg of the seaweed? So first because this is in milligram, we convert into gram, we divide by 1000. So 0.03 gram per kg. Like the amount of iodine in the sample, if we have 1 kg sample, how much iodine is there? 0.03. If we have 10 kg sample, how much iodine will be there? X cross multiply. So it will be 10 times. So it will be 0.3 gram. So 0.3 gram of iodine will be there. Then how the iodine exists? Because iodine is existing as I2. So what about then we'll find the moles of iodine, mass in gram over molar mass. So 126.9 multiplied by 2. Why? Because it's a molecule. This will give us the moles of iodine. And from moles of iodine, how to get the number of atoms? So we multiplied by Avogadro's number, which is 6 exponent 23. So this will give us the moles of iodine and multiplied by, because one mole contains 6 exponent 23. So how many moles we have? According to that, we get the total number of moles of iodine. So it will be 1.42 exponent 21 atoms of iodine. If they ask for atoms, one more thing, because it's written bold atom. So because it is written about the atom, then I will not multiply this by 2. If it was only iodine in 10 kg, so in this case, it will be 0.3 divided by 126.9 into the Avogadro's number, Avogadro's constant. Why I should not multiply by 2? Because in the question, it's written in bold the atoms. So number of moles of atoms will be like we divided by atomic mass. If it was only like written number of moles of iodine, so we have to take that iodine because it exists as a molecule. So they are asking the number of moles of molecule. I did not focus that like atom is bold, so that's why it should divide, not the molecule, I should divide by the atomic mass. The concentration of a sulfur dioxide in a sample of a polluted air is 0.4 parts per million. What is the percentage of sulfur dioxide in polluted air? So concentration in ppm is equals to mass of solute, like in this case sulfur dioxide, divided by mass of air or a sample into 1 million. So concentration in ppm is 0.4. The mass of sulfur dioxide over mass of air, this will be divided by, because 1 million was multiplied here, it will be divided. So 0.4 divided by 1 million. So it will be 0.4 into 10 to the power minus 6. But we need percentage. So if we want to take percentage, so what we simply do, we multiply both sides by 100. Because like it's a mass of sulfur dioxide divided by the mass of air into 100. So when we multiply this, like 0.4 exponent, 0.4 exponent minus 6 multiplied by 100. So it will be 0.4 into 10 to the power minus 4. Or when you write this number, so it will match with option C. So C will be the right answer. So whenever you want to convert the concentration into ppm, we simply multiply, like we solve the question, like we find the ratio of the solute over solvent, and then we just multiply by 100 to convert into percentage. How many structural isomers are there for C6 and H14? Means hexane. Structure, like how many different structures are possible for this compound? So if we draw, one is a straight chain, 1, 2, 3, 4, 5, 6. Then we make a branch. This is one possibility. Then we make change the position of the branch. This is a second possibility. Then we cannot change the branch to other side. It will be same because it will be 2. Now we start making 2 branches. So 3. So this is one possibility. 1, 2, 1, 2, 3, 6 are there. So 4. This is one possibility that 2 branches are on the same carbon, and maybe there's 2 branches on the different carbon. And there's one other possibility. So 1, 2, 3, 4, 5 are there. So C will be the right answer. Like how many different structures are possible for C6H14? That's what we did. Which statement about the polyethylene is not correct? So about the polyethylene, which statement is not correct? It is addition polymer. It decolorizes the bromine. So because polymer contain a single bond, so it cannot decolorize. It's a non-biodegradable and empirical formula of all the addition polymer which are derived from alkene is also CH2. So that is also correct. So, which mixture could be formed when a single molecule of C6, C12, H26 is cracked? So means the total should be C12 and H26. So C4, H8, pentane means C5, H12, and propene means C3 and H6. When you add them, the total should be C12, like when we add 4 plus 5, 9 plus 3, 12. So C12. What about hydrogen? 8 plus 12, 20, and 20. So butene is there. Which mixture could be formed when a single? So when you simply add, so C12 and H26. So the total sum of these products is equals to C12 and H26. So that's why A should be the right answer. Why not B? Like if you take hexane, hex means 6 carbon. So C6 and H14. Butene means C4, H8. And ethane means C2 and H6. So 10, 12, C12 is there, but hydrogen, 14 plus 8 makes 22, and 22 plus 6 makes 28. So this is C12 and H28, but we want a cracking of C12 and H26. That's why A is the right answer. The substance formed when a combustion of a petrol in a car engine include, like when hydrocarbons are burned, you just have to mention the products which are formed by burning or a combustion of the hydrocarbon. Water, carbon dioxide, and hydrogen, totally wrong. Water, carbon monoxide, and hydrogen chloride is wrong. Water, carbon dioxide, and sulfur, because the fuel petrol contain trace of sulfur, so sulfur dioxide is also there. Water, carbon particulates, and hydrogen is wrong because hydrogen is not given off when a combustion happen or occur. So these are the MCQs from the mock. Now we'll discuss the structure questions.